So this is a problem B of the exercise of sequential circuits. So we can start. We can see that the two conditions that we have are ORs. The first OR depends on x plus y negative, and the other one depends on the x and y. And then with this we can do the truth table, and depending on the equations that we already have, we can see that x0 and y0 equals to d1 and the theta equals to 0. And we can go on to the 0 and 1, and then in the d we have a 0, and in the theta we have a 1. And when the x is 1 and the y is 0, the d is 1 and the z is 1. And then look into the equation. When the 1 and 1, we have a 1, and we also again we have another 1. And well, with this we know that the q equals to the d, so we can simplify everything by just putting the same numbers, the same ones and zeros as the d. And then we can go on and do the state table. And well, we are going to check when the x equals to 0 and the y equals to 0, y0 and x0, we have a d1, the d have a 1, and the theta and the z have a 0, so we put it here. And then with the x equals to 0 and the y equals to 1, the d is 0, and we have a 1 in the z. And when the x equals 1, y 0, we have that the d equals to 1, so we put the 1, and this z equals to 1, so we will put the 1. And when the x is 1 and the y is 1, is 1 and 1 again. Well, we can go on to the state diagram. We have only two states, the 0 and the 1 for the current states. And well, we're going to check. We know that the first current goes from 0 to 1, so we make the arrow, and then we check and goes from 0 to 1 again. We route the arrow, and then we see that the states have the x with 0, and the output is 0 again. And when the x is 1, we have also an output of 1 when the state is going to be 1. And then we go on to the next state that tells us that the 1 goes to the 0, and we have this state is in x when x is 0, and we have an output of 1, and we're going to put it here. And then the last one is when the current state goes from 1 to 1, so we made the arrow in the same place, and we have a x1 and the output is 1 again. And that's all. Thank you.